Okay, so today, a rather small class, but we are going to kind of continue on the stuff that we were talking about last week first. Actually, first a note, we're doing it once per week now instead of twice per week because we've actually been moving through the content really fast in those 4 lessons that we had. We moved through, probably each lesson was like a week of content. So we went through really fast, and now we've actually kind of caught up to the point at where the college class that I'm taking is. And so we're going to we've shortened it down to 1 class, and then, so I'm not wasting your guys' time. And then the other thing is, we're even going to probably take a step back and I kind of spend a little bit more time on each of these things, not rush through quite so fast, because before we were actually running through like a week and a half probably of material in a single 2-hour lesson. So today we're going to kind of continue with some stuff we had last week, and then kind of towards the end, if we have time, which I assume we will kind of play around with some of the applications of the stuff that we've created, and kind of get some practice putting these things together. Because now we're starting to get into more advanced topics that you can actually create fun, interesting programs with. So the first thing I wanted to talk about is last week we talked about if statements. And we used the if statements for when we were iterating through a string, which we'll do more of today. But we used it to check if the character that we were looking at in the string was whatever character we wanted it to, and we did kind of some stuff with it like that. So we write an if statement like this. First you have if and the keyword, right? And then you have the test. And so the test will be usually some variable, right, like I, although you would want to name it a more descriptive variable. And also you don't declare a variable within the if. We'd have to declare it out here. So we could say like int let's think, what could we do for an we'll just name it I for now. But that would be a bad name to just name a variable if you were actually doing a program that has some meaning behind it. Now we're just going kind of abstract. So we have I is smaller than 2. And then we put those curly brackets, and inside we say system.out.println, say success. Woohoo! So then if I is smaller than 2, we're going to print out success. If not, we skip this code within these brackets right here, and we move on. So because 0 is smaller than 2, we get success. If I is 5, compile and run, we get nothing, which is what we intended to do. Now, a lot of times, if an if statement fails, you don't want it to just skip everything, right? Like in this case, if we end up failing this test, right? Let's make this a little bit more realistic. Let's say that on our test, we have a test of 10 questions, okay? And if we get 8 or more, then we have passed the class. So we'll name this pass and int questions right, questions correct equals, and we'll keep it at 5 for now. Now we don't want to just tell someone that they passed, right? If they don't pass, we want to tell them that they failed. So we don't want to just write system.out.println fail at the end, because then every time it's going to say that the person failed. Just if they did pass, it'll say pass and then fail. But really, we only want this thing down here to run if this does not run. So you might think, hey, Detlef just said if. So what if I do another if statement and I say if actually, sorry, one thing to notice, if we were doing this passing thing, it would be if I is greater than or equal to 8. For the first one, that would be a pass. So I just changed this right here just to make it make sense with the story. If you get greater than or equal to 8 questions, you pass. But let's say if I is smaller than is smaller than 8, then you fail. And if we run this will... Oh, what did I do wrong here? Oh, sorry, I forgot to change this. This isn't I anymore. This is questions right. Questions right. We compile. We run, and it's going to tell us that we failed because we had questions right equal to 5. I'm going to pause for just a second. Okay, so we could do these two if statements, but I mean, really, you either pass or you fail, right? We don't really need to do a second test, right? We don't need to say, hey, did you pass? Okay, you passed. Hey, did you fail? If someone says, no, I didn't pass, you can assume that they failed. So what we can actually do is, instead of using this if statement, we can use a special syntax called else. And the else statement, it goes right at the end of the bracket of an if statement. And so the if and the else form together an if-else kind of logic right there. So it says, if questions right is larger than or equal to 8, then it prints pass. But else, if that is not true, then it runs system.out.println fail. But if this statement right here is true, it doesn't run the else. So it's mutually exclusive. It only runs one of these each time. And so this will work. We can run this and we can test this out. And now you might not see the point of doing an else instead of just an if, but it is simpler, and we'll get more into complexities of why it's really important to really think about what you want your if statements to be. And we'll work with several different types of if structures. But that's just something to keep in mind, right? If you have two things and they're mutually exclusive, meaning you only want to run one of these pieces of code, do an if-else. Now, let's say, this test, we could pass, right, by getting an 80 or higher. But let's say we really want to get an A, right? That is really what we want to get right here. So we want to get larger than or equal to 9, right? So if we get a 90% or higher on this test, we don't just pass, right? We say like, woohoo, we got an A, right? But if we don't get that one, then we'll just say to ourselves, well, we passed at least, right? So instead of doing another if, right? Because if we do something like if questions right is larger than or equal to, oh, whoops, I split this up. So we say if questions is larger than or equal to 8, right, which is what we had before, then say system.out.println pass. Now we could do that, but then if we try this and we got a perfect score on the test, let's say, compile, and run, it's going to say, woohoo, we got an A, pass. Because when it's going down, it says, okay, is questions right larger than or equal to 9? Okay, print that. But then it goes on, and instead of skipping if questions right is larger than or equal to 8, right, it says, oh yeah, it's also that, so say pass too. But really, we only wanted to say one of those things. Because if it says, woohoo, we got an A, we all know an A is a pass. So, what you can do is a further thing called an else if. So an else if, what that does is that basically, it sets up like a little chain, right? So, we run this if thing, right? And we say, is questions right larger than or equal to 9? If it is, okay, run that code and skip all this stuff and just start from here. Whoops, little typo right there. But let's say if questions right is false, right? Then we move on to the next thing and we say, else, right? Because it's not a whole other if statement, it's else, it's connected. So if that one's not correct, then we do this test right here. And if this test is correct, we run this code and we skip to the bottom. And if that one is still not correct, we go down to the else. And the else says if all those other tests failed, then we run this code right here. So it'll only ever run one of these things, which is what we wanted it to do. Now, something important to notice is that with if and else statements, you can put whatever code you want inside of them. You can put in more if statements, right? Like, let's say another thing we could do is instead of running 3 tests, right? How about instead, let's get rid of that, okay? And we'll get rid of the else part. And we'll just say if questions right is larger than or equal to 8, we say pass, right? But what if, in addition to pass, we want to say with an A, right? So we could say pass, and let's change it to a print, and then we say if questions right is larger than or equal to 9, then we say system.out.print with an A. So now if we have 10 like before, it's going to say, okay, that's larger than 8, so it'll say pass. And then if it's also larger than 9, it'll say with an A. But if it's smaller than 8, it won't even ask if it's larger than 9. So if we run that, okay, it's going to say pass. Oh, I forgot a space right here. But pass with an A. So there we go. So that's if, else, ifs. The other thing to note is that you can do as many else ifs as you want, right? So I could do an else if for 10% and an else if for 30%. I could do as many else ifs as I want. You can only have one else because else is like if everything else fails, right? So only one else, and you can have multiple ifs, right? But those are each going to be tested individually. If you want one if-else chain, right, you can do as many else-ifs as you want. So I could be like, if questions right is that, else if, yada, 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 and then I could do another else if, and another, and another, and another, and I can do as many as I want right there. So that's kind of what we got on if-else statements. The other thing you can do is you can also not have an else statement. Let's say you wanted to do these tests, right? And if one of these tests passes, you wanted to say a certain thing. But if all of them fail, you don't want to write anything. You can just leave out the else. You can do if, else, if, right? Or you can do if, else. Or you can do if, else, if. Or if, else, if, else. So, kind of a big part of working with if-else stuff is you want to think about whether you, or like what kind of structure you should use. And there's a few structures. If, right? And this could be as many ifs as you want it to. But this is if you want to do separate tests on each one. And sometimes this can be useful, right? So if I want to say, if I'm changing the questions right in here. So let's say on the test, right, I got a 50%. But my teacher, he says, well, if you get this question, this extra credit question correct, right, then you get plus 3 points on your exam. So I could set up an if statement and say, if, and I'm just going to write this out as pseudocode. This wouldn't actually run, but if you got extra credit right, then it's going to questions right plus equals 3. And then after that, I'm going to say if questions right is larger than or if questions, right, is larger than or equal to 8, you passed, right? So here, if I'd set this up an if-else if, right, then it would have said I'd failed. If I'd gone like this, because it would have said, did you get the extra credit question right? Yeah, you did, plus 3 points, but it never would have said that I'd passed, because it would have skipped that code. And likewise, if I hadn't gotten the extra credit right, it would have gone right here. So that's where something with an if might be useful, right? If you wanted to do multiple separate tests, or if the thing you're testing on will be changed, because these are different tests, right? First I'm asking, did I get the extra credit right? Then I'm asking what my score was. So that's where you would use an if. If you want something to run, actually, I mean, I think the if, else if, and else stuff is fairly self-explanatory. It'll take some getting used to, and I could run through a whole bunch of scenarios with you, but I think we'll actually move on, because we'll probably hit on this later. So the next thing we're going to talk about is something called a fence post problem. So we're going to kind of step away from ifs for a while. We are going to go back to for loops. So, looks like I'm missing a bracket right there. So add that in. Let's create a function called public static, and we'll say string, because we want it to return a string, and we will say spell word. 1 second. Okay, so we have public static string, spell word, and we're going to use a parameter, remember from last week, we'll say string string word. That's not super descriptive, but that should be fine. So what do we want to do in this thing? Well, I want to pass in a word, a string, that says something like hello. And then I want to turn that into H-E-L-L-O. Okay? So I want to add a dash in between them. And we know how to do this. Okay? So let's set up a for loop, because that's what we're going to be working with, right? Int, we'll call it I equals 0. And what we're going to want to be doing, something similar to last week, is we are going to be iterating through the string. So we want to say I is smaller than word.length. So word.length gives you the length of whatever the word is, because we don't know what the word is right now. So we'll just put that in its place. Then we'll say I plus plus. So close it off with the parentheses, and we'll tab in the center. Now, what we want to do is out here, we'll create a string, and our string is going to be spelled word. And we're going to say it's equal to nothing. It's just blank right now. And so now we're going to be basically adding into that string spelled word. So inside here, let's say char or car or care, and we'll call this care bear, and we'll set that equal to word.care at, and we'll say I. And I just named it bear because that's funny, but it doesn't, just whatever we want to name it. So what we're doing here is care, remember, is a character, and so what we're saying is set this variable equal to the character in word at place I. And as we go through our loop, it's going to go and set each one of those. So it's going to set bear is equal to, on the first loop, it'll be the first letter. So bear is the first letter. Next, we're going to say spelled word equals spelled word plus plus, and then we'll do a little dash, and then we'll do plus bear. So what this is doing right here is it's saying take everything that we've had before right? Because we don't want to delete everything every time. So we'll say, basically add a dash, and then whatever the character is. Now, let's go back up to main. We're going to call this method. So we'll say spell word. We'll pass in, we'll say hello. Let's just check that this looks good. It should run. Oh, what did we? Oh, I forgot a semicolon right there. So, compile. What did we mess up here? Oh, it looks like we're missing a bracket again. So, I'll add one in. No, we weren't. Alright, let me see what this problem is. Okay, so we got these brackets right here. These brackets, these brackets. That should be the right amount of brackets. Oh. That's what it was saying. Missing a return statement. Because, yeah, we're getting the spelled word, but we're never doing anything with it. So what we need to do is we need to say system.out.println spell word. And that's going to print out whatever it is. And then right here, we also need to say return spelled word at the very end. Okay, so now if we compile, this should work. And if we run it, it's going to say more or less what we wanted it to say. But see, we got this kind of thing at the beginning, right? Where there's an extra dash at the beginning. We don't want a dash there. So maybe we go like, hey, I know. We will add a dash right here. We can compile. And we can run. And that's just going to add one to the end. Because really what we want here is we want this to have one less dash than letter. And this is what's called a fence post problem. Now, the way to solve a fence post problem is we're actually going to mess with our loop a little bit. Okay? We are going to change this to I equals 1. Now, why would we add, and we're also going to move this dash right here. Why would we do that? Oops, extra one right there. Well, the reason we're going to do that is because what we're going to do is to kind of get rid of this extra dash at the beginning, right? We are going to basically do the first letter manually without a dash. And this will become more apparent in a second. So you have spelled word, right? And we're going to say spelled word equals spelled word plus, and then we will say word dot char at 0. Now, if we run this, it's going to work perfectly because it's not right here. It's basically adding the first letter in, and then doing the fence posts, the little dashes. So we'll always have that extra letter at the beginning, and that doesn't have its own dash, because that doesn't need a dash before it, right? Because it's the first letter. So that will work. That's kind of how you attack a fence post problem. And fence post problems aren't always this kind of simple, right? They kind of, you'll use the same concept later on. Oh, also the reason it's called a fence post is because it's like, this is the post of a fence. Whoops. This is like the post, and then this is the like bar that's running, or the chain link that's running between the posts or something like that. Okay, so that is that. Now another thing I want to talk about is, let's get rid of this method. And here I'm going to pause and help. Okay, we're back. We'll also get rid of this thing, so we're back to kind of how we started this lesson out. And I want to show you guys something. So we'll say public static void, and we'll just call this one void. And we will say double word. We'll pass in a string word. So we got this right here, and what we want to do is we want to turn hello into HHEELLLLOO, like that. So again, we're going to do a for loop. This is an offense suppose problem, so we can actually start this at 0. We don't have to worry. Whoops. We don't have to worry about putting in that first character manually. So we say I is smaller than word dot length. I plus plus. Also, generally, I'm moving really fast, but it's a good idea to kind of add spacing between stuff like that, and that really makes it more like legible and stuff. I'm running through it really fast, so I'm probably going to forget it. I'm kind of bad about that. I'm just remembering good spacing, but just try and make your code look nice. So we're in here, and we're going to do kind of a similar thing where we say, let's say, string doubled word out here. And we'll set that equal to nothing, just a blank thing. And inside of it, we're going to go care bear. We'll just call it whatever. It's like care bear. And then we'll set that equal to word dot caret I. And then how are we going to double it? Well, here's what we can do. We can say doubled word equals doubled word plus bear plus bear, because we're adding it 2 times. Now we can compile this, and we can run it. Oh, whoops, I never ran it up here, though. So we'll say double word, we'll say hello. Oh, and then down here, we need to run a system.out.println doubled word. Now, if we compile and we run, it's going to say HHEELLLOO. So that's good. That's exactly what we wanted. Now I can see this and be like, what if I wanted to triple the word? What if I wanted to quadruple the word? What if I wanted to quintuple the word? Right? You would keep on adding plus bear plus bear plus bear, but that seems kind of like tedious. Right? So what if I'm like, hey, I'll just do bear times 2, right? It should work the same. I compile it. Hey, it works. That's cool. Let's see what it's going to do. So look what it printed out down here. It printed out this really weird number. And that is due, that is due to a really weird thing about characters, where when you perform what looks like a math operation to a string or a character, because what it does is it says, okay, string plus character, right? So it adds the character to the string, and then it says times 2. And times 2 is a math operation. And here's the funny thing. With strings and characters, they actually all have integer values. So like A is not really a character. It's actually a number. Like that's how it's stored in the computer. It's some like huge number. And so when you do like bear times 2, it takes that number and multiplies it by 2. So that's why you're going to get a weird thing like this. You can't do math operations on that. And there's a good reason for it to do that with the numbers. But for now, like, just kind of stay away from that. If you see that issue happening, go and check. See, like, hey, where am I making this mistake? Where am I doing a math operation on strings? The other thing people do sometimes is they do, like, plus equals bear. Right, because they're like, hey, plus equals, we learned that, right? That just adds on something, right? And, oh wait, that's weird. Oh, sorry, plus equals bear, plus bear. And see, there we go. That's where it's going to mess up. It actually works when we do just plus equals bear. It actually does work, but it doesn't double the word. So just, if you end up with the numbers, come back. Just don't do the plus equals, just kind of, I don't know, just try and stay away from those math operations. If we wanted to add, 4 or 5 characters to this thing, and we didn't want to have to type out bear 5 times, something we could do is we could do another for loop nested inside of this one that added bear 5 times, right? We won't, or actually, we'll do that. You know what? We will do that. So let's say we have a class constant up here called public static final int. We'll say num of multiply. That's really long. And we'll say this is equal to 5. But basically what I'm saying is this is how much we're going to multiply the word. So when we say double word, it's actually going to multiply it by 5. So then if we go down here, we can do a nested for loop and say for int j, because we can't use I, because we're already using I. J equals 0. J is smaller than num of multiply. And that was a really bad variable name, but whatever. We'll stick with it. And then we could say doubled word plus or equals doubled word plus bear. Now if we run this, it's going to print out, hello with 5 things, and we could change this to 4 or 3 or whatever. So that's a way to solve that problem without running into the integer problem. Okay, so excuse me. We are now going to look at something very interesting. This is kind of a new thing for us. Because up till this point, our programs have only ever done one thing, right? Like, sure, you could change the code to make it do different things, right? Like, we could change this number right here before, or even 45, right? And I mean, yeah, technically that changes the code, but if we don't change this code at all, it's never going to change, right? I could run this program 1,000 times, and it's always going to say 45. Or it's always going to say this hello thing right here. So what we're going to do is we're going to start doing things where we don't know exactly what our program is going to do beforehand. Now, that might be a bit confusing. Basically, what we're going to be working with is user input. So allowing the user to type things in. This is really what programs are for. You want to get user input. Why do you have equals right there? Okay, I'm going to pause the video for a second and help with some errors, and we'll be back. So, we are going to work with user input, like I said. We're going to be working with something called, let me delete all this stuff, called scanner. Just give me 1 second. Okay, so scanner is part of a Java library, which I talked about before, right? And actually, before we use scanner, we're going to have to do some work. Because scanner is not something that's built into Java. It is a class that the people who wrote Java wrote to make getting input easier. Now, they have this stored in what's called the Java libraries. And there are some classes, right, like math, like string, that are so often used that they just automatically put them in Java for you. But there are other classes, like scanner, that they aren't so common that they always put them in there. Because you might not need them, right? So what we do is we have to import it. So this is our first example of code that's going to go above the class. So we go to import, or we go above the class where it says public class. Above that, this is our first code that's going to go above this. We're going to say import Java dot util dot star. Now what this means is we're basically saying, okay, go to the Java library, which is that huge thing, go into the util, which is the utility folder, and then the star means give us everything in that folder, all the classes in there. Now you might think, hey, that's kind of not good programming, right? Because then you add a whole bunch of stuff that you don't really need, right? If you just do star and you add all of it, you don't need all that library, so why would you do that? And here's the thing, Java is actually smart enough that you can say all, but it'll only ever import what you need. So we're saying, hey, kind of allow us to use all of this stuff, right? But if we don't end up using it, it's not going to take up memory or anything like that. So we're going to say import java.util.star. I'm pretty sure that's the correct library. I might have to go check. So next what we're going to do is we're going to say scanner, and this is the scanner object, similar to a string. See how it's capitalized? And we're going to call this console. You can call it whatever you want. And then we're going to say equals new scanner. And then we go system.in. So basically what we're doing here is we are constructing a scanner. This right here is actually a function called a constructor. And then what a constructor does is it creates one of the classes. It creates a scanner. And what we're doing right here is we're passing in system.in, which system.in is the input. But system.in is kind of hard to use, right? It's not as easy as system.out, which is super easy. That's system.out.println, right? That's super easy. We've done that a bunch. System.in is more complex. So what we do is we give that to the scanner that we just created right here, and then the scanner is going to do work with that and basically make it easier for us to work with input. So we pass that in. And I mean, this is kind of complicated. I don't expect you to know all of this, but just kind of know this is how you declare a scanner. Now, let's do something fairly simple. Let's define an int I equals 0. System.out.println I. And this will print out, if we run it, this will print out 0. And let's see, is it going to run the scanner? Yeah, so it's going to print out 0. Now here's how we add in the user input. We say console, right? We're referencing our scanner. We're going to say dot next capital I int, and then end that with a little parentheses. And then I'll explain what this does in a second, but let's just run it for now. Hey, it's gonna do it like this, and it didn't print out anything. Or at least it looks like it didn't. What it's actually doing is it's waiting for us to type in something. See, I can type in whatever I want. I hit backspace. So let's say I'm going to type in 5, right? Now it's not going to do anything until I hit enter. It's actually waiting for me right now. The program is just sitting there waiting for me to hit enter. And once I do, it sets int I equal to whatever I typed in, and then prints that out. Now, something to know, pretty much always, right? You want to print out something before you ask for input. Because otherwise, it's going to be like us, where at first we thought it just didn't print out anything. So and if you have a user who's using this, who probably doesn't know how to program, you don't want them to think that the program's not working just because they're waiting for them to type. So we'll say something like, type number here, colon, space, and now when we hit compile and run, it's going to say type number here, then we can type in our number and then it'll print it out. So that is kind of generally how you do scanner. So that is only how you do it with ints though. And what we want to do is, sometimes we want to do, for example, a double, right? That's easy enough. You just go next, change the int part to double, and obviously you have to save this in a double. So we say next double, compile, and then we can type in 2.5 and it'll print out 2.5. We can even type in 2 and it'll know, hey, let's make that into a double by making it 2.0, and it'll print that out. It also works with strings. So let's say type message here. And let's say we wanted to get a message to send to a friend. Like maybe this is a messaging app, right? So let's say type message here. So first of all, we want to say this is a string, right? And you might think, hey, next string. Nope, you just do next. Compile, run, and what next does is next will grab the first word being separated with spaces. So if I say hello, it'll save this. What I typed here is hello. If I type in hello there, it's still just going to say hello, because it only gets that first word, right? Now, let's say I actually wanted it to get a whole line, right? I wanted it to save everything on that line. You would say next line. Compile, run, and now I can say hello there, my name is Detlef. And it'll save that whole thing and run it. So that is how we get input. And that's kind of a very basic application of it, where we're just getting it in and printing it out. But you could do something like, let's set up a class called public static double multiply. And we'll pass in a double num. Now inside of here, let's say we want to multiply, or actually let's say a square. Okay. And actually let's make these ints, not doubles. So, public static int square int num. And then inside of here, what we want to do is we want to do num times num, and we want to return that, because we're squaring the number, right? So public static int square int num, and then return num times num, which is the same thing as squaring, multiplying it by itself. So we return that. Now let's go up here, and let's go in here, but actually let's not pass in num, right? That's how we've done it before. But what we really want to do is we want to get some input. We want to say console.next int, and we'll store that in int num equals console.nextInt. Right, and then that'll store that in num, and then we can multiply it. But it's going to say error cannot find symbol variable console. And why is that happening? That's because console only exists out here. It doesn't exist inside of here. So what we actually want to do... Oh, also the other thing is we never ran this program. But so we'll say square, and we'll say, also system.out.println square, so we can actually see what we've squared. And then inside of here, we're going to pass in console. And in here, we'll take a parameter of type scanner and call it console. So now if we compile and we run, it's going to ask for a number, and we should have printed out something to say, hey, we're waiting for you to type in a number, but let's say 5. And it's going to square that, give us 25, and print that out. So, like, that's an example of something you can do with scanner if you want to do like a calculator type thing. Yeah, scanner is good for just getting input from the person. Typing in a username and a password, for example, is something you could do with scanner, right? Say, hey, username, and then hey, password, and then if those things match what you have saved in your program, say, hey, you've logged in, you're good. And so there's a lot of applications we can do with scanner, but I mean, it's really just a way to assign variables, which is nothing new. So we're actually going to move on to something else called indefinite loops. Because when you have a program, right, like let's say a calculator, for example, it doesn't just run once and then shut off, right? Like that's what our programs have done before. It runs, it prints out its stuff, and then it ends, right? Maybe it runs through a few loops, but eventually it ends, and it always ends at the same exact time. But really, when you have like a program like a calculator, for example, or a video game or whatever, you don't want it to just run through once and then end. You want it to run a bunch of times, right? But you also don't want it to run, for like 24 hours and then the user only uses it for like 5 minutes, right? You want the user to be able to determine when the program ends, right? I mean, even simpler than that, sometimes you want to not know how long sometimes you don't know how long the program is going to go on for, right? Like it could be, again, this is called indefinite because you don't know exactly how many times each loop is going to run. And so, actually, this is kind of complicated, but I think what we'll do is we'll just kind of type this out, and this will make more sense. We're going to learn about a new type of loop called a while loop. Now, we've done a for loop before, and I'll tell you there's actually a way to do for loops in a way that makes them exactly like while loops. But that's bad programming. Don't do that. I'm not even going to talk about that. A while loop goes like this. You go while, and then you do some sort of test. Let's say int I equals 0, and we'll say I is smaller than 4. And then inside, we will say system.out.println x. Now if we compile this, this is going to compile fine. And if we run this, it's going to print out x over and 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 over again. And it's going to keep on printing, and it's going to freeze even a little bit. And we're going to say end run. End run, stop running, please. Because it's got trapped in an infinite loop. Because what while does is, think of while like an if statement that runs forever. Okay? So basically, the while loop is going to run this code while I is smaller than 4. And because we never change I is always going to be smaller than 4. So it will run on forever and ever and ever and ever until we actually have to pull out a stop and terminate it via JGrasp. But so what you could do inside of here, right, is you might say, for example, let's say this is a program that prints out x, right? And we let the user determine, hey, how many times do you want to print out x? So let's say int I equals console.next int, right? So that's going to get in some input, and we will say I is smaller than 1. So now if we run this, oh, whoops, what is it saying? Oh, I didn't need to say int I, I had to say I. So we'll compile, and we will run. It's going to say x, and then it's going to wait for me. And if I say 0, it'll run again. If I say negative 1,000 or 100, it'll run again. But if I say 1, it's going to end the program. So what we've just done right here is we've essentially created a way for the user to hit exit on the program, right? The user can say, basically has a quit button or a quit command now. So, this program could run 1,000 loops. It could run 1 loop, right? And this is what I'm talking about with indefinite. This is where the user is determining how many times this loop runs. So, that's kind of the interesting part with while loops. And that's really what you want to use while loops for. Don't forget about for loops completely, because for loops are still incredibly useful. But for some cases, while loops are better. For example, in this case. Now, let's that is really most everything I learned last week in my class. Now what we're going to do is we're going to actually, kind of for the first time, do a little bit of a project here. we are going to just do a quick, very simple video game.
Yeah.
Now, this isn't going to be super fun video game because all we know how to do is type in text, but we can do some fairly interesting stuff still. We're going to create a dice game. Now, one thing we want to know and really deal with before we work with games is that with games there's usually a factor of luck, right? And here's the thing: a computer is a completely logical machine. There is no possible way for a computer to generate something truly random. But we can get, no, not even a random number generator. That's the thing. A random number generator is actually not truly random. But there is a way to get computers to give you numbers that look random. So what mathematicians have actually found is they have found certain algorithms that create a random distribution of numbers. It's not actually random because it's an algorithm, right? But it creates a distribution of numbers that is very large and everything is very well kind of dispersed. There's no like clumps of 9s or clumps of 1s. And so when you want to get a random number, your computer it has this big library of numbers, and how it will decide what number to get from that library is it will take something that's really hard to guess, right? Like it is always measuring time, right? So let's say it is saying the time in milliseconds, thousandths of a second, since it asked or since it it could be a bunch of things, like its last processor refresh, the number of milliseconds since that, something that there's no way any human could ever predict, right, could ever know. And it'll say take that number and use that to find a random number in this sequence. So that was really complicated, and you don't really need to know all that stuff. What's important is we're going to use another class, and I'm pretty sure it is also in java.util. So I don't think we need to add anything, but the class is called rand. So we go random equals new rand. Now let's compile this. Let me make sure that this is working. Okay, so I'm going to have to reference, actually, so I'll pause this for a second. Okay, so I looked it up, and I was a little bit wrong on the naming. It's not rand, it is random, and then usually what people call their random class is rand. So I got that a little bit mixed up. But so it's rand equals new random. Parentheses, this is another constructor. Don't worry about that, just know that this is kind of the magic incantation that creates you a variable that creates random numbers called rand. So now that we have rand, right, let's kind of get rid of this stuff. System.out.println rand.nextInt. So this works kind of the same way as a scanner, right? But it's going to return us a random number. So we compile this, we hit run, and it's going to give us a random number. Literally, a very random number. Negative 155038027. This is, whatever it is, 15 billion, 15 trillion, or whatever it is. It's giving us this huge number. But usually you don't want a ginormous number like this, right? Usually you want something that's within a certain range. For example, if we want to roll a dice, we want something between 0 and 6. Or, sorry, between 1 and 6. So let's put in the number 6. Right, and what this is going to do is it's going to make it only generate 6 different numbers. Oh, but hey, right away we can run this again and it'll give us a different number. Because it's random, right? But hey, what's this? 0. There's no 0 on a dice. Right? When we say 6, it says, okay, I will give you 6 numbers. But again, remember, computers start counting at 0. They don't start counting at 1. So, the way we can fix this is by adding +, plus 1 to the end of this. And this will basically turn 0 into 1, 2 into 3, 4 into 4 into 5, 5 into 6, and this will generate from 1 to 6. So if we run this...
6 to 7?
No, it won't turn 6 to 7 because rand.nextInt 6 will never give you 6.
Oh.
It will give you 6 numbers, but those numbers are 0 to 5, not 0 to 6. If you want to get 0 to 6, you'd have to put in 7.
I have an error.
Okay, so I'm going to pause and help with an error. Okay, so I forgot to unpause, but basically what we did is we went through and we said, okay, so we declared this random, right? And we said int roll equals 0. And this is going to be, we're creating a game where basically you roll a dice until you get a 6. And depending on how many times you rolled the dice before you got a 6, that determines whether you get a prize or whether you lose. So we have int roll, which is whatever number you're going to roll. And right now we just set it equal to 0. That's just to start off, we're just defining stuff. Then also, we want to know how many times we rolled it. So we declare num of rolls equal to 0. So then we say while roll doesn't equal 6, that's what this means right here, not equals. While roll not equals 6, right? So if we roll a 5, that's not equal 6, so it'll run it again. Then we run this code in here. So the first thing we do is we come in, roll is 0, because that's what we defined it as. So it says, okay, it's not equal to 6, so we run this code. So we say roll equals rand.nextInt 6 plus 1. And I don't know if I talked about this or not, but this is how... shoot, I forget if I talked about this, but... so this is how you declare a random variable. Rand.nextInt will return you a random number. And if you put in a number like 6 right here, it's going to give you, it'll give you a choice among 6 numbers. However, this isn't like you'd think. It's not 1 to 6. It won't give you 1 or 2 or 3 or 4 or 5, 6. It'll give you 0 to 5 because computers start counting at 0. So in order to get it to be 1 to 6 instead of 0 to 5, we add 1 to whatever number we roll. So 0 becomes 1, 1 becomes 2, 2 becomes 3, and on and on and on. So after that we say, hey, you rolled a, and we write out whatever number you rolled. Then we add to num of rolls because you just rolled the dice, right? And so then each time you roll and it's not a 6, or each time you roll just in general, num of rolls will increase by 1. Then after it's done rolling, after you get a 6, it'll tell you you rolled this many times. And then depending on how many times you rolled, it'll either say you won, choose your prize, or you lost, better luck next time. If you guys have any questions on that, feel free to ask me, because I did kind of miss out on that. But yeah, I got a process to fix it. Okay, I'm back. So that was kind of a very, not a great game, because we're not taking in user input. This is more to show you what rand can do. So, I'm gonna pause this while I think of a game for us to create. Okay, so I decided on the program we are going to create. This is going to be a rather complex program. We are going to create Yahtzee. Now, we're not going to create actually a Yahtzee with scoring and all that stuff, but we're going to create a program that will roll the Yahtzee dice and allow you to like save them. Because if you guys have ever played Yahtzee before, you roll the dice and you can choose to roll. You roll first all the dice, then you choose which dice you want to roll, and it saves the number of dice that you have. So let's start off with, first we want to just define a scanner, console. So console equals new scanner system.in. Next, we should declare our random. So we're going to say random rand equals new random. So we got those two things. Now, now this, let's create a function, public static void, public static void roll we'll say roll die. This is kind of we are actually, in order to create this program, we are actually going to do all of the code in main. Now this is actually not a great idea. This is bad programming, but for now we don't know how to do it with functions. So really focus on what the code is, not so much on where it is, which is all in main. So let's declare int die1 equals 0, int die2 equals 0, int die3 equals 0, int die4 equals 0, int die5 equals 0. I think there's 5 dice in Yahtzee. So we have all of our dice kind of declared out there. The next thing we're going to do is we're going to say, well, first we're going to roll all of them. So what we will do is we will go die1 equals, and let's create a little function just to make this a little bit simpler. We'll say public static int roll, and we'll take in random rand, and inside this is going to be a really short function. It's just going to say return rand dot next, oh my gosh, there, okay, next int 6 plus 1. So this is basically just going to roll our dice and return a number. So we will say return this. So then if we go up here and we say roll rand die2 equals roll rand die3 equals roll rand die4 equals roll rand die5 equals roll rand. So this is going to roll all of the dice. And then we are going to system.out.println dice colon space, oops, and then we'll say plus die1 plus, and then we have to add a blank space right here to separate them, plus die2 plus space plus die3 plus space plus die4 plus space plus die5. Now if we compile and we run, it's going to roll our 5 dice. And it'll give them a different number each time. So that's good. Now we need to give the person an option to choose which dice they want to roll. So we are going to say system dot out dot println which die do you want to re-roll? We have to put this in a string. And actually this will be a print, not a println. So we'll say print question mark, add a space at the end. Then we will do console dot next int. And we will say we'll define that, and then we will store that in int choice equals console.nextInt. Then we say if choice equals 1, then we're going to do something kind of weird here, but trust me out. Die 1 equals 7. That's going to make no sense right now. Pay attention. Then we say else if choice equals 2. It's going to get kind of messy, but die 2 equals 7. Okay. Whoops. Didn't need that. Else if, and this should not be else is, else if choice equals 3. Die 3 equals 7. There we go. Else if choice equals 4. Die 4 equals 7. And then else die 5 equals 7. Okay, so let's compile this, just make sure we don't have any errors. Illegal start of expression. Oh, okay, so we missed a colon, or a bracket right there. Compile. Now it works. So basically, based on whatever choice they make, they can set these dice equal to 7. Now I'm actually going to put this into a loop. So while let's think for a second. Okay, so we were working on a Yahtzee kind of simulator type thing, but frankly it got way too complex, way too fast, and there are some things that we don't really know yet that we're supposed to do. So yeah, I kind of wanted to have a real game that we made, but Yahtzee was probably a bit too ambitious. So we had the carnival game. And that'll kind of end it for this week. The lesson will be a little bit short. But we are making good progress in terms of the lessons. So that's it.